Hello, today we are going to talk about stabilization of soils with cement. Our group members are Eduard Fuentes, Duan Santamaria, Laura Valentina Santamaria, Juan Ariza, and Oriol Leal. Introduction. Soil is always a fundamental element for civil engineering projects. For this reason, they must have the appropriate quality and resistance characteristics. For different environmental, economic, or other reasons, processes such as soil stabilization are used to avoid the transport of materials. Soil stabilization is a process that improves the physical and mechanical properties and resistance of soils. In general, this is achieved by blending and mixing soils with other materials such as cement. Objectives: improve soil to the desired quality, avoid transportation of materials, and improve soil support and shear strength. Next, we will talk about cements used in this process, dosing methods, and some advantages and disadvantages of the soil stabilization.
Cements used for soil stabilization. It is possible to use different types of cements. The most suitable cement is the one that meets next condition. First of all, we have the price of the material. There are cement enterprises in Colombia like Argos, Cemex, Holcim, among others. A 50-kilogram package of cement costs between 25,000 to 30,000 Colombian pesos. The soil type. In Colombia exist several types of soils of sedimentary origin with a considerable content of calcium carbonate. These soils are expansive with low or high plasticity, like CH, CL, MH, ML, among others. Therefore, its load capacity is low, doing that deep than being necessary add to the mix major quantity of cement. The material availability. The transport costs depend on the distance from the cement factory to the place of work. It is necessary to find the nearest place to buy the cement in order to reduce prices. Then, we can look the initial process to soil cement mix, where people put cement package in a distribution to mix the material with the help of a backhoe. It is necessary to evaluate the improvement aspects of the soil cement mix. We evaluate three aspects. First of all, we have the heat of hydration, where a low heat of hydration reduces cracks in the stabilized layer. The rigidity, considering that the stabilized soil layer presents an increase in her rigidity, decreasing permanent settlements. And the last one, the durability, where the increase of the resistance provokes an increase in the durability of the stabilized soil layer.
Let's continue with dosing methods. The dosage of a soil stabilization with cement for explain is to obtain the optimal combination of cement, soil, wear, and wear appropriation. Activities that meet our technical specifications set on characteristics in a furnace and Herner state. Next. The properties must be maintained for small variation of the components. In addition, the mixture must be worked for a sufficient time and easily compacted. Next. The dosage of cement stabilized soil comprises several phases and definition and characterization of the materials make you the soil stabilized with cement, laboratory determination of the working formula with the proportion of the different materials, verification and adjustment of the work on-site formula. Thank you.
Equipment used in the application. There are several machines that are used for soil stabilization. These are the most common in Colombia and the rest of the world. The first machine in the list is the spreader, also is called like creep. It is used to put the semen on the ground using a specific quantity. Then we have the recycle. The function of this machine is pulverize the soil and mix it with the semen in a fast and efficient process. Later, we have the motor grader. This machine it is responsible of spraying the mixed soil semen and extend it in the layer of the subgrade or GSB according to the geometrical design. Then we have the vibro compactor. Once extending the soil semen mix, these machines compact the recycled material until it reaches the specific density according to the geometrical design. And the last one is the rod tanker. That is used to distribute the optimum moisture content for the mixing and curing process.
Well, now we are going to talk about the advantages and disadvantages of semen stabilization. In the advantages, we have semen stabilization increases base material strength and stiffness, which reduce deflection due to traffic loads. This delays surface distress such as fatigue, cracking, and extends pavement structure life. Semen stabilization provides uniform strong support, which results in reduced stresses to the subgrade. This reduces subgrade failure, furrow formation, and rock pavement surface. It's commonly used for stabilizing sandy and other low plasticity soils. Semen interacts with the steel and clay fractions and reduces their affinity from water. The strong, uniform support provided by semen stabilization results in reduced stresses applied to the subgrade. A thinner semen stabilized section can reduce subgrade stresses more than a thicker layer of untreated aggregate base. Subgrade failures, furrows, and roughness are thus reduced. In the disadvantages of semen stabilization, we have soil degradation. Soil semen has the disadvantages of injuring the soil. When semen is added to soil, microorganisms are destroyed and organic matter is converted into the non-organic collage. As a result, soil structure change and air capacity decrease due to the expulsion of water after mixing with the semen proteins. Elimination of soil organisms. Mix soil semen with the soil microorganisms and their enzymes entail a certain date rate. Also, we have if the percentage of semen is too high, it is going to create a crack. It is not sustainable from some type of soil. If soil moisture is more than 10%, it cannot work. It's harmful for the environment.
Sustainability in engineering has a great impact in this era, mainly in road works. It has become necessary to achieve the sustainability of the pavement through innovation in the materials that compose it. Thanks to the stabilization of soils with semen, this has been made possible as they contain environmentally friendly plasticizing additives. In addition, such stabilization for temporary roads is carried out with the granular materials of the site, cement and machinery. This reduces the exploitation of quarries, benefiting the ecosystem. In this way, it is not necessary to transport materials from other territories, so we contribute to the reduction of CO2 pollution. Thanks for the attention.